We're going to look at another one of those portable power stations today. This one's the Maxoak by Bluetti, and it features wireless charging for your phone. It also has 4 USB outputs and 1 USB-C, 3 12-volt outputs, and 2 sine wave AC outputs. We're going to put it through the paces, look at the waveform, and see how it performs. Let's check it out. Today I'm going to look at a power station, a portable power station by Bluetti. I guess that's how they pronounce it. This one's the model AC50S. I haven't even opened this one yet. So let's crack this one open and see what's in the box. It was a bit noisy around here this morning. I couldn't film earlier because they were tearing a house down at the corner. So all you could hear was boom, boom, bam, bam. I should have gone out there with my camera, but I didn't. But here's the 2-year warranty on this one. There'll be an accessory pack. I'm sure this is going to have all the connection cables in it, which it does. Comes with a, what is this? That's your charger brick. So this one actually uses a brick to charge it up, as opposed to plugging the power directly into it. And a variety of cables, like for charging from a car. Comes with a USB-C to USB-C cable, which is nice. And of course the AC power cord. Let's look at the unit itself. Then I'm going to charge it up, and we'll put it through its paces and see what it does. This, by the way, is rubber. It's got a rubber cabinet, or it feels like rubber, probably synthetic rubber, but it does have a rubber cabinet. It's got a light on it too. Input. This is for charging it. On the back side, we have power, DC and AC. Got 4 USB outputs, 4 5-volt 3-amp outputs, and a USB-C, which will put out 45 watts. This one here is a pure sine wave 300 watt output, so it's a little bit lower power than the other one. 12 volt 10 amp output. It's also got a 12 volt 3 amp, 2 12 volt 3 amp outputs on it, and a light. So the first things we're going to do with this one is I'm going to plug in the charge cord and let it charge up. To charge the unit, simply plug. This is a special adapter, by the way. I think it's probably about 19 volts, and it looks like a laptop. It looks like a laptop adapter, but we'll check out the specs here. Fan has come on to indicate it's going to be charging at a fairly good rate here. It's 27 volts output at 3.25 amps. So this is a special power supply for this unit. We're going to let this, and you know the light turns red when it's charging. Light's green when it's not charging, or I guess when it's fully charged it turns green. When it's charging, the light turns red. So I'm going to leave this thing sit here while I go out for a ride on my bike, and when I get back, oh, nice color display, cool. When I get back, the battery should be fully charged. It looks like it's sitting around a 50% charge right now, so I'll let the battery get to a full charge. It shows us how much power we're putting in. We're putting in 84 watts from the charger. So I'm going to let this unit charge up for a while I go have my lunch and take my bike out. It's a nice day. I'm going to take it out for a ride. And then we'll come back once this is charged up. We'll try it out, play around with it, see what it does. And possibly, if I can figure out a way to get into this thing, maybe even open it up. Here's our specs on this one if we want to look at the specifications on the bottom. So it has a 500 watt hour 11.1 volt 45 amp hour battery. The DC input to charge it is 12 to 40 volts DC at 120 watts input, so it can be charged from solar panels as well. And it actually does come with connection cables to charge it from a solar panel. Right, it does come with the connection. You plug your solar panel into there charge it up. So perfect for someone who wants to operate off-grid, like for, say, powering up a cabin or your campsite. I can't see someone using something like this for a cabin because it's only a 300 watt inverter. The other one that I had, that I reviewed before, could do much more power. It could run a 1500 watt fry pan, for example, with no problem. This one here is limited to 300 watts. So this will operate your smaller appliances and communication equipment like charger phones, run some lights, run a television, DVD player, that type of stuff, satellite receiver, no problem. This will run that, but you're not going to be powering up a fry pan or a toaster with this because it's only 300 watts. But for camping, this would be a very good solution because it's relatively small. It can be charged up on the go from solar panels or from your car, and it'll give you that 300 watt output that you can power your AC, your smaller AC appliances with. If we look down at the output, the AC output 100 to 120 volts, 50 or 60 hertz, switchable. Has USB 5 volts at 3 amps. Type C output, which is 5, 9, 12, 15 volts at 3 amps and 20 volts at 2 1/4 amps. Has two 12 volt 3 amp outputs and a cigarette lighter socket, which is capable of 12 volts at 10 amps. And it also has wireless charging, 5 watt and 7.5 watt and 10 watt wireless charging capability. So right here on the top, if I turn the unit on, if I take my phone, put my phone on top, my phone should go into charging mode. Or do I have to turn it? Oh, I have to turn it on. Let me turn on the DC power. I think that's the one I gotta hit. There we go, the button on the front for DC power. That should, I think, I haven't read the instructions yet, but that should turn on the wireless charging, which it has. So you turn on the DC power, and you can just set your phone on top. Another nice feature. So if you're traveling, you have a DC, you have a wireless charge station for your phone or your tablet or whatever, that you can just drop your phone on top and it's good to go. Another neat feature. Anyway, let me finish charging the battery. Looks like it's not going to take that long because it's at like 80% now. But let me finish charging the battery, then we're going to put this thing through its paces. So now that the battery is fully charged, let's just take a look at the specifications and then we'll go over the operation of the unit. So it has an output. There's two different versions available. There's a 100 to 120 volt AC, as well as a 220 to 240 volt AC version, depending on the market. Rated power 300 watts with a peak power of 450. And as it says, 300 watts for load, 450 for start up 120 seconds, and 450 watt load at 1 second to or less than 450 for up to 120 seconds. 450 watt load for 1 second, it's going to shut down. You can switch between 50 and 60 hertz. The DC output is 12 volts to 12 to 14 workable 10 amps output. Your DC output, there's also a 9.6 to 12.6 DC regulated at 3 amps, which is more like for running LED lights, etc. It's a BC 1.2 for Apple and Samsung. Rated voltage 5 volts at 3 amps. A PD 2.0 at 45 watts, which is 5 volts 3 amps, 9 volt 3 amps, 12 volt 3 amps, 15 volts 3 amps, and 20 volts. That's your USB-C output, or the PD output as they call it. Wireless charging is a Qi 1.2.4 for most devices. Most devices that have the Qi charging. Output power 5 watts, 7.5, and 10 watts. It says when the power is on, if you press the LED light to turn on the light, there's a light on the back. It's a 3-position, full brightness, half brightness, and SOS mode. I haven't got into that yet. Input power for charging 12 to 40 volts DC, up to 120 watts maximum. The battery capacity is 500 watt hour, and it's 11.1 volts lithium ion. Voltage range 9.6 to 12.6 volts. And there's your environmental protection, IP21, and the unit weighs around 6.2 kilograms. And then it has some of the troubleshooting on here. Don't need to look at that. Pretty straightforward. Let's turn it on and see what it does. So to turn it on, press and hold or press the power button. It'll show me the status of the battery. To turn on the DC output, I can just press and hold the DC button, and that will turn on the 5 outputs here, as well as the two 12-volt 3 amp outputs, which would be used for like powering up LEDs, etc., as well as the 12-volt 10 amp output used for powering up, say, portable refrigerators and so forth. For example, I can plug in a conventional USB device, such as my phone, and it'll go into charge mode, tell me that it's going to be 35 minutes to fully charged, because this is a standard charge rate on this one. If I put in the USB-C plug, it'll then charge my phone at the higher voltage. So plug in USB-C to USB-C, and it still tells me 35 minutes to full charge. My phone's almost charged. So it's got a 75% charge on it right now, so it's not like my phone is going to probably charge up that much quicker. So there's the two charging ports, conventional USB and the USB-C. So I say you can also just drop your phone if your phone supports wireless charging. You drop your phone on top, it's going to charge up. To turn on the inverter, press and hold the AC button, and that'll turn on the AC power, and green light will light up on the front to indicate that it's on. So now I've got both the DC power and the AC power on, and it also shows you on the display. It shows you the switch is on, right? If I turn it off, it'll go off. I'm curious what happens if I plug my heat gun in. Now we know that this thing's going to draw way too much power on high, but how about on low? Now this thing does draw, it probably will overload this on low as well, but let's see what happens. Will it even start it? And it will. And we are drawing 241 watts on low. But at least it allows the unit to start up and operate. If I turn it into high power mode, it's going to shut down, guaranteed. Which it does. And let's just see whether it'll reset itself or whether I have to turn off the power. I probably have to turn the AC power off and then turn it back on. There. Now I can operate it again. So it will provide enough power to start this unit up, but it's limiting my power consumption to 240 watts. As you know from the prior one, this thing will actually draw about 600 watts when it's on low power, and 1400 or 1300 on high power. But at least it's providing me some operation, showing me how much power I'm using. We'll check the voltage out and see what type of a voltage drop we're getting. I'm sure that the voltage is probably going to drop when I'm drawing that kind of current. So we'll put the voltmeter in AC mode and we'll check our voltage. We have 122 volts. When I turn my heat gun on in low power, oh, we still have 120 volts, so the voltage did not drop. So I've got full power at 120 volts. Okay, it's dropped a bit, 117. And that's because the current, it's trying to draw more than 300 watts. So surge will allow it to draw excess of 300 watts up to 450 to get an appliance running, but then it's going to limit the current to 300 watts, and as such the voltage has dropped a little bit. I've now plugged the charge power back in. As you can see, it's supplying about 73 watts, 80 watts of power. Will the AC output operate when it's got power charging it? Yes, it will. So we're still getting our 236 watts AC out, our charge power is still at 80 watts. So obviously this will discharge the battery, but it will of course extend the life of the battery because some of that power will be drawn from the input. That's important for someone who's using this with a solar panel. Say you've got a solar panel, you're at your campsite or your cabin or wherever you're using this for your AC power, and you've got some permanent solar panels set up to keep the battery charged. So you can keep your solar panel set up that will charge the battery, and you can still be using your AC output. But obviously if you're using more power on the AC output than you're putting in on your charge, you are going to discharge the battery. But at least when you stop using power, it'll recharge the battery. So here's the output on my scope, using my digital scope this time because I can read the frequency, 60.06 Hertz, RMS voltage 121.06, which is pretty close to what my fluke meter is measuring. And here's our waveform. Waveform looks relatively clean here. It's a sine wave. But this is under no load. So let's throw this thing under load. And we'll see that our voltage dropped to 114 volts. Our frequency is still 60 Hertz. And we're still relatively clean. A little bit of distortion in the waveform here, as you can see. A little bit of a wave shape has changed slightly, but it's still a relatively clean sine wave. No load, back to a full sine wave. Now remember, I'm loading this to its limit with this. Basically, it's like a hairdryer. It's a heat gun on low. But I'm basically I'm taking this to its limit. I'm pushing all the power that this inverter is capable of delivering. And it's still holding out pretty good. Now under full load, they say that, what did they say here for time wise? It should run under full load for about 2.5 hours. They're saying a 200 watt electric stewing pot drawing 200 watts should run for 2.5 hours, and I'm drawing about 225 watts. So it should run for a couple of hours, approximately. The times that they say it will run, it'll charge up 25 smartphones for 2 hours each at a 10 watt load. You can run 80 watt electric tools for about 6 hours. 20 watt LED lamps will run for 25 hours on a 20 watt load. A 90 watt refrigerator should run for 5.5 hours. And then a 75 watt LCD television should run for 6.6 hours. That's 75 watts. So it all depends on how much power you're drawing as to how long it's going to run. But looking at the waveform here, with the current that I'm drawing on this, it seems to be putting out a fairly usable signal. And the voltage has dropped a little bit. It's dropped down to 110 volts now, but that's still well within the range that most devices are going to function properly. And we're seeing a little bit more of a waveform distortion here, but not too critical. I'm curious as to what type of battery they use in this, what type of cells they use. Maybe that requires a teardown to see how this thing's built. Also on the back, there's a light panel. Turn it around. Has a nice LED light in the back. Press the button once, it's full power. Press it again, it's dim. Press it 3 times and it becomes your SOS. So, great for camping. If you're camping, you've got this thing sitting on your picnic table. You've got some ambient light. You can plug your devices in, charge your phone, whatever. Nice little unit. Now, I want to take this thing apart, but I'm having a tough time trying to find where the screws are. Are they under here? They're not under the feet. I looked there. There's no screws there. Fan's still running because this thing, well, of course I had it under load there for a bit, so it's going to cool the battery down a bit. But I don't see any readily available screws. I'll have to investigate and see where this thing comes apart. Well, there's one screw under that. I already pulled one foot off and there was nothing, so maybe there's not one under each. There's one under that one. It doesn't look like there's anything under that one there. So maybe there's only 2 screws that hold this thing together, because that one doesn't have a screw either. But looks like there's a couple screws here. We'll are they screws or are they security bits? That looks like it might be some type of a hex key. It's way down too far for me to access with anything. Unless there's other screws on here that hold this unit together, I may not be able to pull it apart as much as I'd like to. I'd like to show you guys what this thing looks like inside. Maybe there's something under this rubber. The rubber skin. I think it's the same screws. Has carrying handles for ease of moving it. Anyway, that's a look at the Bluetti, I guess that's how they pronounce it, 120 volt inverter. Nice little unit. Looks like it would do the job for many people. And also, of course, just as a backup power supply if your power goes out. Anyway, that's about all I can show you on this one. I want to tear it down, but unfortunately it's not accessible, so I'm just going to charge this thing back up. And we'll catch you guys in the next one. Thanks for watching.